The Creation Museum, I mean, you made it all the way through without putting your head through one of the dinosaur displays. Did you do anything on it on your channel, or, you know, have you profiled?
I do. It's actually my best performing video. It's got 150,000 views right now. It's my documentary, my opus, right? My summer project. And I went through the Creation Museum and I took as many pictures and as much video as I could, and I did a long, detailed, well-sourced takedown of the science behind it, or lack thereof. Of course, the greatest hits are pretending that the speed of light can be changed to that the speed of light is variable to the degree that you can cram, you know, 13 billion years of the universe's history into 6,000 years. That's excellent. And they do the same thing with genetics, right?
Given the biblical time scale that God created the universe roughly 6,000 years ago, how are we able to see stars and galaxies that are billions of light years away?
There's more than one way God could have done it. The method I think that he used doesn't involve any kind of supernatural activity at all. Of course, God can do, you know, God can do miracles. That's not a problem for God. So we dare not say, well, I don't understand how you could have done that, God, therefore you didn't do it. Well, that's absurd. I mean, you'd have to eliminate the resurrection and turning water into wine and all these things. But the way that I think that God got the light here is, I think that the Bible is using a synchrony convention that's different from our modern synchrony convention. Now, what's a synchrony convention? That's the idea that two clocks separated by distance are synchronized. Well, how do you decide if two clocks separated by distance are synchronized? Now, if the distance is short, it's pretty easy. You just look at them and you say, well, they're both synchronized. But if light takes some time to get from that clock to your eyes, then that might be a little bit of a problem. They might look synchronized, but in fact, one of them's a little bit of ahead of the other, but it took more time for the light to get from one than the other. So you see, it becomes a little bit of an issue when the clocks become separated by cosmic distances. And it turns out, this is something that Einstein wrote about, it turns out that there is no objective way to synchronize two clocks separated by a cosmic distance without assuming the speed of light in one direction. And when I mean the speed of light in one direction, most of the experiments that have been done to measure the speed of light involve either directly or indirectly a two-way trip. It's like you're taking light from a source, you're sending it out, bouncing it off a mirror and bringing it back, and you're measuring the total time, the total distance, and you divide the distance by the time. That gets the average velocity. And a lot of times people assume that it takes the light the same time to go that way as it does to go that way. We don't really know that. And in fact, according to Einstein, it's impossible to know that. People say, why would it be different in different directions? Well, I don't know, but there's no reason why it would have to be the same either. And I found the concept's a little bit difficult for laymen to grasp because it takes a little bit of knowledge of the physics of Einstein. And so I actually wrote a book about this topic called The Physics of Einstein, where it brings people up to speed on the physics that they would have to know in order to recognize why you can't actually objectively measure the one-way speed of light, because you'd need two clocks that are exactly synchronized, and there is no objective way to do that in the universe. There are subjective ways to do it, where you can say, I'm going to call this synchronized, and somebody else is free to disagree and say, no, I don't think they're synchronized. I think they'd be synchronized if this one was turned a little bit ahead of that one, so that now they're synchronized. And the bottom line is, if you use the ancient method of synchronizing clocks, which is a visual synchrony convention, clocks are synchronized if they look like they're synchronized, basically, then light takes no time at all, even today, to get from those distant galaxies to the Earth. And so it can actually arrive instantaneously. And that doesn't violate any physics. It's actually perfectly consistent with the physics that Einstein discovered. It's just that a lot of people don't know about it. And I know that's a little bit abstract. I found that it takes probably at least 20 minutes really to bring people up to speed on the basic issues so that they can comprehend the thrust of the argument. But I do have a series of articles on our website at biblicalscienceinstitute.com. Our latest articles are on this very issue. I've been bringing people up to speed on the Starlight issue, some of the other solutions that have been proposed, and why I think this, what I call the anisotropic synchrony convention, is the best method. It's consistent with the physics of Einstein. Nobody can disprove it. It makes sense historically. And in that model, light can get from the farthest galaxy to the Earth immediately. It takes no time at all. And therefore, there is no distant starlight if you understand physics.
Awesome. That was a great answer. Matter of fact, even going back to your debate 2 months ago with you, Ross, he objected that your distant starlight argument by asking, when we look at the sun, do we see the sun as it is now or as it was 8 minutes ago? right? So it appeared
Right.
that by asking that question, Hugh Ross didn't fully understand the physics of Einstein. Now, what would be the best response or argument to that specifically?
Yeah, yeah. When he asks that, when he asks, is it this or that? It's like asking, is a table 3 feet long or is it 1 yard long? And of course, the answer is both. It depends on what units you choose to make the measurement with. And so whenever anybody asks that question, you know, does it take light 8 minutes to get from the sun to the earth, or does it get here instantaneously, or 16 minutes? And the answer is it depends on the synchrony convention that you choose. There is no objective answer to that question. People get frustrated because most of us have a view of time that it's sort of absolute and universal. It's the same everywhere. Clocks all tick at the same rate. Everything, you know, you don't have to worry about these synchrony problems. But Einstein discovered that is not the case. Time is not the universal objective thing we think it is. It's affected by motion, gravity, and things like that. And so the amount of time it takes light, now the amount of time it takes light to get from A to B and back to A, that's objective, and that time is objective. And there's no getting around that. The round trip speed of light is set by God in vacuum. You can't change it. But the one-way speed depends on how you choose to synchronize clocks. And so does light take 8 minutes to get from the sun to the earth, or does it take no time at all? The answer is yes. And the same is true for distant stars. Does it take years for their light to get here, or does it arrive here instantaneously? The answer is yes. It depends on which synchrony convention you use. And I believe the Bible's using the more ancient synchrony convention, in which the celestial events are marked by when you see them. And so in using that system, God created the entire universe. The light was immediately visible to Earth on day 4, as soon as God created the luminaries. And that gets around a lot of these other issues too of, you know, people saying, well, God made the light already on its way. Well, then he's making pictures of things that don't exist. This gets around all that, because all the stars that we have pictures of really existed in real time. It's just that we see them immediately.
Oh, I love it. Great answer. We've got a lively chat who are really enjoying this, and who really enjoyed your debate with Hugh Ross a couple months ago, and share my opinions with it. Here we've got Tony Torpa. Question came in. Hi, Jason. Has anything been heard from Hugh Ross when you challenged him to read your article, Distant Starlight and ASC, in your last debate? Thanks for your new posts on the subject. They are awesome.
Thank you for that. No, I haven't heard from Hugh Ross. I hope that he did look at that article, because he was under the mistaken impression that light from a supernova could be used to measure the one-way speed of light. It cannot. And I had already answered that, because there was a critic named Peter who had posted that same thing. And I demonstrated that, in fact, Peter had made the assumption in his question that the speed of light's the same in all directions. Otherwise, his question wouldn't make any sense. The fact is, you get exactly the same answer for when you see the light from a supernova that's been gravitationally bent. You get exactly the same answer, whether the light in one direction is instantaneous, or whether it's C, or whether it's any other value that's allowed. And the reason for that is light can only be instantaneous in one direction relative to a given observer. And so the light from the supernova would have to go at an angle. And so it wouldn't be quite instantaneous when it first goes out, until it gets bent around the galaxy and then zips directly toward the observer. And so I answered that, and Hugh hasn't got back with me yet. I hope he will. If he wants to, if he thinks I'm wrong, he's welcome to challenge me, and I'd be happy to post his reply and my reply to his reply, and so on.
Awesome. Yeah, great response. I mean, it looks like oftentimes I find that the critics, even some of the most militant critics, just aren't really up to date on the literature on this anyways. Yeah. So I guess you kind of answered this, but a question would be, how do you feel the critics have responded to your arguments overall, Dr. Lyle, on distant starlight in a young universe? For example, as you're covering here, the one-way speed of light and synchrony conventions. In other words, have they provided any sufficient rebuttals? And if possible, and you did cover a couple here, what are the best possible responses to those rebuttals?
I haven't seen any serious rebuttals, to be honest with you. People who are physicists and are trained in relativity have, some of them have said, well, Lyle's right about that. So, and of course, some of the papers that promote an ask type model, like the one by Sarkar and Stachel that I like to point out, and the authors are not creationists, but they agree that light can get here instantaneously using the correct synchrony convention. So I haven't seen any real. I've seen internet rebuttals by people who don't seem to be trained in relativity, I've seen one that says, well, no, you can't use that coordinate system, or it would create a gravitational field, which we don't see. No, that's not the case. Switching coordinate systems does not create a gravitational field. You can measure things in polar coordinates. You can measure them in rectangular. You can measure using an Einstein synchrony convention or the anisotropic synchrony convention. It doesn't create any magnet or any gravitational fields. And anyway, it actually the most of the ones, if you go back a few months back on my website where I respond to Peter's objections on distant starlight, most of the ones that I've seen on the internet, he repeated those and I answered them. So I haven't seen any ones that are a serious challenge from a physics perspective, because frankly, the conventionality thesis upon which my model is based is really pretty well established. I consider it proved. John Winnie back in 1970 showed that all of special relativity can be done without the one-way speed of light, leaving it as a free parameter, which the epsilon, the Reichenbach epsilon. So I haven't seen any rebuttals at all, really, other than ones that are kind of on the internet, not peer-reviewed ones.
For the sake of argument, let's accept that your claim for the round trip average speed of light is 186,000 miles per second. If this is true, and this is the one-way speed of light, then in order to accommodate a 6,000-year time frame, these specific critics have stated that there is simply no reason to think that the one-way speed of light is over 700 times faster than the round trip speed of light.
Well, when people state things that way, that suggests to me that they're not understanding the physics of the situation. It'd be a little bit like saying, the metric system is clearly the correct way to measure things, and not the English system of feet and inches. I mean, because 12 inches in a foot, I mean, that seems unlikely. Whereas meters, it's 10 centimeters, 100 centimeters in a meter, and so on. That's all 10. That's nice and neat. Nature clearly prefers metric over English. Well, no, it doesn't, because you see, when it comes to a convention of measurement, you can't use Occam's razors. Well, it's more likely to be this than that. No, it isn't. It's your choice. The English system, in terms of inches and feet and foot pounds and so on, it is a lot more complicated. It's hard to keep track of than the metric system. It is. That's why scientists, we like metric. And we do all our calculations in metric. And then if we need to convert at the end, we can. But that doesn't mean that English units are wrong. And it's the same way with the one-way speed of light. It's not that it's this or that or the other. It's what you choose it to be, and that will tell you how to synchronize two clocks that are separated by distance. And I know that's counterintuitive, but folks, if you're gonna, if you're gonna argue on this principle, you need to get up to speed on the physics of this. This has been discussed. This topic of the one-way speed of light and its immeasurability has been discussed for over a century. There's a century worth of literature out there devoted to this topic. And not long ago, I came across a book somebody had written. Max Jammer wrote a wonderful book called Concepts of Simultaneity from Antiquity to Einstein and Beyond. And it's a nice summary of the scientific literature, written really pretty much at a layman level. And so that's a nice way to get up to speed on these issues. But when people say, well, it's more like the speed light's more likely to be this and than that, or there's no evidence that it's one way or the other. No. This is a convention of measurement. It's a convention by which we decide what we're going to call synchronized when we have two clocks separated by distance. That's all it is. And that's why there is leeway in terms of how you choose to set the one-way speed of light. It's not something that can ever be measured. It's because it's not an objective property of the universe. It's a human choice.
Right. That's a great response. These critics, like you said, Dr. Lau, they need to get up to date on this. This physics, as you said, is known and it's understood. And it's probably why you have not had any convincing rebuttals. So that's a great response.